All right. So this is kicking off really five short lessons we'll have about this actually incredibly cool technology called Docker. Um, Docker is an example of something called a Linux container, which is you can think of it as a lightweight virtual machine, and it has become a key technology for DevOps, for deploying for the to the cloud, and even for front end or full stack and back end development because of how easy it is to set up whole environments and systems using this technology. Um, so why is it important? It's important for deploying to the cloud. It's important relatedly for DevOps and continuous integration, continuous development pipelines, and for developer environments or dev environments. It's very likely you will encounter Docker at your first job, and it's like in GitHub kind of becomes standard knowledge. Um, and the good news is there's actually something like similar to Docker that we're all probably familiar with, which is a virtual machine. Anyone anyone here ever used an emulator to play a PlayStation game or a Nintendo game on the computer? Yeah. So as you folks may know, you use the virtual machine to do that. Someone want to give me like the short, like 2 to 3 sentence description of what a virtual machine is?
Essentially, it's an OS running inside of an OS. So, like, you could run Linux, which is not really an OS, it's a kernel, but inside of a Windows machine. And
Yeah, thank you, always.
there's multiple ways to do it. Or I guess a virtual machine's not a dual boot. So, yeah, it's still running on that machine's designated RAM, but you're partitioning it to where that virtual machine takes up some of the RAM.
Yep, exactly. Can everyone read this diagram okay, by the way? And let me go ahead and I'll pull these guys up so that they're a bit more centered. Um, is this readable? Perfect. So over here, we've got an example of a virtual machine. And then over here, we have an example of, you know, a computer without a VM running, without a virtual machine running. And just to kind of walk through these bits, and when you kind of hit the highlights, our normal computer, and let me zoom in a bit here. With our normal computer, like first off, there's the hardware layer all the way at the bottom. There's the actual central processing unit, the CPU, the random access memory that someone remind me what RAM is versus say the hard drive. What's our difference here again?
So
Temporary
more,
storage?
yeah.
Say that again.
Temporary storage?
Yeah, exactly. When I turn my computer off, whatever's in the RAM is gone. Um, and why would does such a thing even exist? Like, why do we have RAM? Why don't we just have a big hard drive or solid state drive?
It's a lot quicker to access.
Yeah, exactly. RAM is way quicker to access, right? Solid state drives have gotten better, but back in the day when a hard drive was like an actual sort of like disk that spun that you had to like magnetize bits of and a read write head that was basically sort of the electromagnetic version of a turntable, it was way slower. Or even before that, it might have been stored on actual like magnetic tape. And even with solid state drives, RAM has gone faster. right? And this leads to the hard drive, which I'm calling storage here, which is where we stick stuff that we want to stick around when we turn off the computer, which is where everything in the file system lives, right? Everything in the file system is on our hard drive. Then we have networking. There's the actual Wi-Fi card, which sends out radio waves so we can, connect over Wi-Fi network. There's the actual hardware for an Ethernet port or whatever it is that we have these days. I didn't include like USB ports and stuff like that, but there's all the physical things, Bluetooth, right? Another little chip that's got a radio on it. And then there's input and output, I/O, the actual keyboard, the mouse, the screen. So this is all the hardware. And the operating system controls access to this hardware so it can be done correctly and safely and efficiently. And the operating system has a kernel, which is sort of the core bit of the operating system, like the key components, including the stuff that accesses all this hard drive stuff. And you guys have probably heard the term Linux kernel. And that's, again, these core parts of our operating system. And then inside the operating system, we run whatever program we want, right? I run Postgres, I run Django. On my laptop, I run Chrome, and so on. And actually, as long as I'm kind of just walking through sort of this computer architecture 101, do folks have any questions or stuff that you are curious about? Cool. And this is a massive oversimplification. Even when I learned this in school, it was an oversimplification. These days, the CPU has multiple chips. Like on the CPU, there's memory called cache. RAM has gotten fancier. Everything has gotten fancier, like a modern car engine versus like a 1950s, car engine. Um, a virtual machine, like you were saying, Owen, is a piece of software for simulating a whole operating system. And so, from the perspective of my programs running inside this virtual machine, and the virtual machine runs on a piece of software called a hypervisor that controls access to the actual hardware. And I guess I'm actually missing a layer here. I do apologize. Um, what layer am I maybe missing in this diagram? I actually did not do this on purpose, but this is a good question asking moment.
Docker?
We haven't added Docker yet. Otherwise, you would be in the ballpark. Um, it's a little subtle, but I got so excited about, you know, the VM and stuff that I forgot that it's not like we don't have an operating system all of a sudden. This hypervisor program still needs to run on an operating system. And really, there's a kernel, right? The OS kernel is here as well. I just forgot it in my diagram. But so, on my laptop, I'm running my OS, my operating system. Then let's say I decide to use a virtual machine. I'm going to use one called VirtualBox. And I would install that software, and that's the hypervisor software. And then it runs this virtual machine. And from the perspective of anything running inside this virtual machine, it's running inside a piece of hardware. It's sort of like Inception. Like if I use a virtual machine that emulates Super Nintendo to play Nintendo games like Chrono Trigger, then Chrono Trigger doesn't know it's not running on an actual Nintendo machine, on like an actual physical piece of hardware. And this offers a number of advantages, right? It means that the VM still needs access to these things, right? It obviously needs to run on RAM. We need to be able to save stuff to the file system, some networking and stuff. But all this stuff is sort of simulated inside here as well. And our hypervisor controls access. One thing that virtual machines are sometimes used for, I believe, is security related stuff. Because if you run something inside a virtual machine, if something goes wrong inside the VM, it kind of stays inside the VM and it has very controlled and limited access to the real operating system. And I think there's actually a chip on the CPU that like is what enables the hypervisor and the virtual machine to work. I don't think you can have virtual machines inside of virtual machines. Though don't quote me on that one. The other nice thing about all this is if I decide to, I can have two virtual machines running on the same computer. This is a little bit of a trick question. Any thoughts as to why we might want to do this?
You might want to use a Windows virtual machine on one and a Linux on the other, or Red Hat, maybe.
Yeah, that's a great use case, right? And actually, that's really common. And for those of you on Windows using WSL2, that is indeed a virtual machine letting you run Linux as well as Windows. Um, Another reason this is useful, and this is the trick question part, and forgive me, I don't know why TL Draw makes it so hard for me to grab the stuff I want, is if if I have a really beefy server, like a really like you know, and storage, maybe I want to become a data center and let people rent server time. And maybe instead of buying like four separate physical computers or servers, I just get one big fancy one and I can run a bunch of VMs on it. And then each of my clients that wants to have a web app running can have their own virtual machine on the server. And this is, in fact, how modern data centers work. Though, what modern data centers do, and Google sort of pioneered this, is they actually use really cheap hardware and just switch it out a lot. But you can have multiple VMs running on one machine. And so this is how the cloud is built. Essentially, it's massive data centers full of servers that are all running virtual machines. And another advantage of this, and forgive me because we haven't gotten to the Docker yet, is let's say that what happens if this server crashes? Well, if we have a backup of my virtual machine, if I can ever, there we go. If I've been smart enough to save a backup of this, a snapshot of the entire state of basically a simulated computer operating system, file system, and the whole shebang, I can run it on another machine. And so, in fact, if I need to do a migration and I'm changing something in my data center, I can move a VM from one physical piece of hardware to another. So virtual machines offer a lot of flexibility as well. And I just want to check in here and see what's on people's minds and what questions folks have, because I've sort of covered a lot of ground here. Um, I know, but it's really useful, I think. And so just to sort of recap, what we've learned is that the cloud is a bunch of servers in a data center. And let's make that bigger, running virtual machines, right? And I don't know if you guys have you guys seen pictures of data centers and how crazy these things are? I'm seeing some nods. I'll throw one up just for an example. Right? Racks upon racks of server hardware, all of them running virtual machines. These things, they build them near electricity sources because they suck up so much electricity. Like there's crazy cooling that gets involved because so much heat is generated by the computers. And so before the quote unquote cloud, we had data centers. And then at some point, just this technology got better and better and better. And it used to be you might have you deal with your actual virtual machine on the data center. At this point with AWS, the whole thing's been abstracted away. And all I know is I have a virtual machine running somewhere on some data center, more or less. Though you guys are learning more about that with the AWS cert. Um, do folks have like, any questions, things that you're curious about or wondering about when it comes to virtual machines, the cloud, just what I've been going over thus far? Okay, cool. So this brings us to Docker. And let me zoom back in a bit here on my TL draw. Actually, let me go ahead and let me zoom it out and bring it over and let's compare. So Docker only runs on Linux and it's a lightweight virtual machine, just like a virtual machine. The hypervisor needs to run inside the actual host operating system on the host system, right? So here's the host system, and I really should have drawn the OS here as well. Um, so let me just make a blue square for that real quick so we can see it properly in our diagram. Um, Docker uses a technology called Linux containers, and as the name hints, it only runs on Linux. And we'll talk about how I can use Docker on my Mac in just a minute, but to give you guys kind of a preview, it involves a virtual machine. So Docker containers are sort of like virtual machines, but they're more lightweight. This is a subtle distinction, but note that in this diagram here with virtual machines, there's an OS kernel. Here, there's not a kernel diagram, and that was deliberate. Because since these containers always run on Linux, the core of the Linux operating system, the kernel, the part that interacts with CPU and RAM and storage and all that, is shared. And in fact, Docker containers can share memory and maybe the hard drive, bits of the hard drive a bit more. So I might have a bunch of Docker containers, but they might have shared access to the same bits of RAM. On a virtual machine, it enforces a real strict segregation. So like there's no way to kind of unofficially pass info between one VM to another. I can't, it controls like which bits of RAM or which bits of the hard drive you access. With a Docker container, there's more shared resources. And a Docker container is basically just a fancy wrapper for a Linux container. And I'll talk about in a minute why this is so useful. And the architecture that we're going to end up doing is a Docker container running Linux, a Docker container running Django, and then a Docker container running Nginx for our React app. We're going to have 3 separate Docker containers, each of which has one piece of our system, and they'll be able to talk to each other. Right? Now, why are we using Docker containers? Why aren't we just using virtual machines? Forgive me as I scroll around here. That's what I want. Can everyone read this okay? So there's some important differences here. The big one is resource usage. Docker containers and Linux containers are way more lightweight. It's not running a full-on guest operating system the same way a VM is, because they share that Linux OS kernel. So they use less resources, which means they boot up way faster. Docker containers, because they're sort of a simpler technology and they leverage Linux, and for some other reasons not worth getting into, they're more portable. VMs rely on specific hypervisor programs, which can depend on certain hardware configurations. With Docker, if you've got Linux, you've got containers. In terms of isolation, a virtual machine gives you more. There's that full system isolation. Dockers only isolate computer processes, which we haven't talked a lot about, but it's not worth going into. And what this boils down to is Docker containers end up being more scalable. I can use way more of them. To go back to our cloud diagram, what the cloud really is here, it's not virtual machines these days. It's probably like one virtual machine and maybe inside of it, a whole bunch of containers, because it's way more lighter weight. Or there might not be a virtual machine at all, and it's just running Docker containers or Linux containers. So just to recap, a virtual machine runs on a hypervisor. It completely runs a whole guest operating system. Programs running inside a VM are they're inceptioned. They're living in the dream and they think the dream is real. They think they're on a real piece of hardware, but they're not. Docker containers aren't quite so inception-y. They only run on Linux. They share an operating system kernel. And they can share some other resources as well, which makes them way more lighter weight. So I just want to check in and see if folks have questions or what's on people's minds. How are we feeling thus far? Because I know I've been doing a lot of talking and just throwing a bunch of concepts out there.
When you say it only runs on Linux, are you saying it don't run on Windows or
That is
can run
correct.
on?
That is exactly the case. So how do we run Docker on a Mac or on Windows? The answer, let me get rid of this annotator, is ironically enough a virtual machine. So me on my Mac, in order to run Docker, I need a virtual machine running Linux. And those of you on Windows, you already have this because WSL2 is a Linux virtual machine. So this does add an extra step to our otherwise kind of beautiful setup. And let me go ahead and throw in the virtual machine. And I think that should be the right color. And this virtual machine is running some flavor of Linux. And we indeed need some sort of hypervisor. Now, Docker has created like a pretty, I don't want to say customized, but sort of tuned virtual machine specifically for this. That's pretty lightweight. There's other ways to do this, but for those of you on Mac, you will want to download and install Docker Desktop. And it certainly won't hurt to install it for Windows. I think WSL2 is already set up and kind of configured to work nicely with it. It's literally a one-click install. I don't have it running at the moment. And when you install it, it just says Docker. And it's a little hard to see, but there's a little whale up here. And that's the Docker desktop. And so now I have started a really like kind of tuned lightweight virtual machine, but a Linux virtual machine nonetheless. And this is a history of different Docker containers that I've run in the past. And we'll talk more about containers and stuff. But James, that was an excellent question. And here, I can manually start and stop. They call it the Docker engine. But it's some sort of virtual machine under the hood. And so on Linux, I wouldn't need this. I think I still need to install Docker for something for the Docker engine, but you don't necessarily, you might want Docker desktop for the user interface, but you're already on Linux. Again, on Windows with WSL2, I think you all should be already set up. But again, I would just install Docker desktop. They've set it up very nicely. And in fact, here they address questions about WSL or WSL2 for Windows. They say it remains the same whether you're using WSL or Hyper-V is a virtual machine hypervisor. So you all should just install the Docker desktop and it'll work basically out the box with WSL2. Yeah, again, great question. And so just to recap, this does add an extra layer, but in practice, we don't really have to think about it. When I'm using Docker on a Mac or a Windows machine, I do need to run a Linux VM, but Docker has done this work for us with Docker Desktop, so it's pretty much a one-click operation. Any questions? What's on people's minds?
I have a question. So on our project, I'm pretty sure we're running like two servers, kind of sort of, when we run our uh, Django channels, which is like a WebSocket. So
Yep.
would we need like four different Dockerized containers?
Uh,
Technically?
good question. Um, so if I wanted to, and let me do this over here on the left. There's nothing stopping me from in one Docker container having my full stack. And you guys see where I'm doing this on this leftmost part over here.
Yeah.
And in fact, in some ways, for learning purposes, for simple stuff, this kind of makes sense. You put it all inside one container and it makes it really easy. We'll see in a moment how easy it is to share containers. And sort of how Docker is set up to kind of build pieces on top of each other like this, like stacks of pancakes. Um, and so for some things you do this in practice, you usually separate out the big parts of your system. So like I think if you guys are running Redis, you might want to run that. That might be its own separate Docker container. Depending on how many pain points that adds, maybe you do want it on one single container with Django. And the other reason that this often happens is, right now for your group projects and for local development, we're always running stuff on one computer. But to go back to the cloud for a minute, this is kind of out of scope, but like a real world production deploy might look something like this. Um, and then we've got what Nginx for our web server. And then I'll put Postgres back here just to sort of show the layers. And then Owen, if your team is using Redis, you might in like a real world situation, in fact, you might want everything to pass through your Nginx web server. That's often done for convenience, for security reasons. But each of these could be in different data centers if we've deployed to the cloud on separate servers or virtual machines. You know, when we do local dev, this is all on one machine. But real world deployment environments these days, you're often running these on separate servers, and the reason is scalability. Because as my app gets bigger, maybe I need to have like 2 instances of the Django API server running. Maybe I now need, and now this web server up here is for React, right? This is what serves up our React.js application. And over here, we've got the user. I'm just going to make a triangle. I don't know why. The user's browser, right? And I could be in Kathmandu and I interact with Nginx, and Nginx, let's say we've gotten really successful and we have a lot of traffic now. So we have so much traffic, we have 2 API servers, and I want to stick, oh, a load balancer in there. If I could find a diamond. And again, this is a bit out of scope, I realize. This is sort of like system design 101. And that book I mentioned yesterday is the thing to look at to kind of dig into this more. And the load balancer's job is to distribute traffic. And those of you who have gotten to this point in the AWS prep course will have encountered it. And you know, if our data gets big enough, maybe we need to shard the database, so to speak, and have Postgres across multiple servers as well, which adds some other complexities not worth kind of getting into about how this works. But that's the reason why you often see parts of a system in separate containers, is because if we start to get lots of traffic and we have to scale up, we can spin up multiple instances of it. Again, this is out of scope. This is a bit more advanced, but I think the context is useful to understand like why Docker exists, why is it used, and as to your point, Owen, why are we going to put Nginx and Django and Postgres in separate containers? Why not just put them all in one? Does that help answer your question, Owen?
Yeah, it does. Thank you.
Awesome. Yeah. What else is on people's minds about this system stuff or with Docker or anything else? Because these are great questions. Cool. All right, let's take a bit of a deeper look into Docker. And I tend to run long, so we may have to get to the part where we actually start using it with Postgres tomorrow. But I think that this sort of conceptual preview is really useful. Um, Docker is cool. What makes it really cool is what's called Docker Hub and and images. And can you all see this okay? So the great thing about Docker is people have done the work of setting up what's called a Docker image. And that is like if you like ran something inside of a Docker container, saved it, and took a snapshot of it, that's a Docker image. The same way I was kind of like grabbing, the VM before and pulling it over here. I always get my terminology a little confused. I'm not exactly sure if container should be here. Like a container is what you start and stop, but an image is like a single file that I can send to you, and you can run inside a Docker container and have this whole stack and all this code already set up. And so Docker has gotten used more and more for developer environments too. Because if you join a company, maybe there's Postgres, maybe there's Redis for caching or for real-time chat with WebSockets, maybe there's Nginx. And as a front-end dev, I might not be an expert at that stuff, and that stuff might have gotten a bit fancy. So there's some Docker containers, and I can run one command to pull down this image and to start it, and inside that container on my computer have that whole system starting. Basically, think about all the pain points you guys encountered with InstallFest, with making sure Node.js was installed, the right version of Python, installing Postgres, installing PyTorch stuff. And now kind of imagine all that going away because you can just pull it down from a Docker image and run that Docker image. And so that's why this is something you're almost definitely going to encounter because it's often used for developer environments. There are some trade-offs involved with that, but that's sort of the essential idea. And I wanted to pull out PyTorch because we'd seen this a bit in class and use this as an example. And if I can find, so just like with GitHub and commits, different, you can save the image at different points, and that's sort of the best practice. And we'll see in a minute how this works with Docker files and stuff. And you can see, by the way, it says the operating system, Arch, which is a flavor of Linux. And if I click on this, what do we get here? Image layers, which I'll talk about later. And we don't have to worry about this stuff. But what I want to find, if I can remember where they put this, is the actual sort of GitHub. So we can see what this actually looks like. Where did they hide it? Yeah, my apologies. I knew it was hiding around here somewhere. So it looks like this is the official PyTorch library. And in here, they have a Docker ignore, by the way, for Docker. But then they have a file just named Docker file. And I'll talk about it in a minute, and what it is. But I want to point out just one or two things here. And I wanted, again, the important thing here isn't to understand each individual line. I just want us to look at the big picture, and I wanted to use PyTorch because this is something that you all have seen and gotten your hands on. So every Docker file starts off with what's called a base image. And this is some other Docker image. So this is using an Ubuntu Docker image. And if we hop over here, back to the Docker Hub and we search for Ubuntu, if I can spell it right, we see the official Ubuntu Docker image. And it tells us how to use it. It tells us how to use it in a Docker file, how to run it. It tells us what ports get exposed. We can see the different versions of it, which version of Ubuntu this is. And somewhere around here, and I can never figure out where they hide the link, but is the, there we go, the Ubuntu Docker image itself. And it looks like this is just the Docker docs. So again, I'm going to Google GitHub Ubuntu Docker. And in fact, it looks like it's hiding in the Docker library. And yep, I'm having trouble finding it. This is someone like configuring Ubuntu for stuff. You can see like right here, this from, it's using a previous Ubuntu Docker image and then configuring shell environment variables and all these other things. So I don't want to get too lost in the sauce here, but the point is somewhere in there, there's a Docker file for the Ubuntu Docker image. And again, it's kind of inception-y. You can build a Docker image off of a Docker image. And so we see here that PyTorch is using this Ubuntu Docker image that's already created. And this is all command line stuff. Environment variables, the from base image, they give it a name. Run is running command line stuff. Windows people will be familiar with apt-get. Mac people, this is a package manager like brew. So think brew update. And then all these things that we're installing. And then we're running a bunch of Linux commands. We're making a directory. We're creating an environment variable. And we're just doing a whole bunch of stuff, installing Python, installing Conda to manage Python versions, creating a directory that PyTorch stuff is going to go into, and more 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 and more. And then we finally kind of wrap up and there's a working directory and we're copying something from outside the operating system and putting it in. But point being is whatever all this stuff is, it's what whoever put this image together decided is how like Ubuntu should be optimally configured and PyTorch should be optimally installed in Ubuntu for us. Right? So someone has done all this work. And so if I look for Docker, Django, Nginx, Postgres, well, I don't want the tutorial. What I want is, let's find Django. And if I can find their GitHub, here we go. This one's okay. So someone's created a configuration for Docker and Django, and let's see what they do here. So they're starting from an image that has installed Node.js already, And if we looked for that Docker image, it undoubtedly would be built off of some version of Linux. It creates a directory for us. It installs a bunch of things we need. It sets up a user for node, blah, 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 blah. Now we add to that Python, we just stack these images on top of each other. And so what we kind of end up with here, if I can draw here, is and forgive this terrible drawing. We're just building image on top of image to build up like one final image. And there's a whole bunch of other stuff here. And then you can see some commands that get run. So I've kind of jumped around a lot, but to make this a bit more concrete, let's take a look at Docker and Postgres. And I think what I'll do is I'll very briefly talk about the different parts of Docker and then just show using the Docker Postgres container. And that'll be a good stopping point for today. And then we can pick it up tomorrow and delve a bit more into Docker. And I'll show you, hopefully tomorrow we'll be able to get to Django as well. So they make it really easy. Once Docker is installed, all I need to do is run this run command right here and give it a password and give it a username. Note that this image already has created a Postgres user and a Postgres database, the stuff that we had to do in InstallFest. They give us instructions if we want to use pSQL instead. And then we have Postgres running inside a container, basically. And there's some information on environment variables and things for how this container is configured. But let me just walk through the different parts of Docker and then show it in action to you guys. So, and forgive me for jumping around a bit. Docker's got a couple different bits. And I'm kind of drawing from a couple different curriculum docs. This is actually in the DevOps curriculum. And this week I will sort of clean up and organize it better in our curriculum. We do have some stuff that goes through Postgres, which I'll show you. But there's more things that I want to add. So the Docker engine we've sort of talked about. This is Docker Desktop. This takes care of the virtual machine and all of that. Docker images, I've sort of been bouncing around and showing you guys, and we're going to see in a moment just how easy it is to use a Docker image. And that's how you share these systems, these environments, and then a container that runs an image. So Docker Engine is the runtime. It's got the virtual machine. It's got a program running in the background. There's a command line interface named Docker. A Docker image is the thing that we share that's running on the server in the cloud or on my laptop. It's lightweight, it's standalone, it's executable, it's got code, it's got a runtime, it's got a Linux operating system, it's got everything. And then we run an image inside a container. So we've got the engine, we've got the images, and we've got containers. And my apologies, I'm jumping around a bit here. Let's go ahead and use this Postgres container. And it's shockingly easy. And I'm just going to leave this up here and I'll put it on the right. And let me grab, I'm just going to use the terminal for the moment. We'll write some code in a minute with a Docker file. Can everyone read this code okay?
Maybe zoom in like one or two.
Yeah, you got it. How's that?
That looks better.
Thank you. And thank you for letting me know. And again, sorry that I'm jumping around a bit here. So a couple things. Now that I've got the Docker desktop running, I can use this to see. So these are images that I've installed and or created. There's stuff for Django, and in fact, here's the Postgres image that's been installed. And I pulled this all from Docker Hub. So the same way there's npm.js that has node packages, or PyPy that lists all the different Python modules available, Docker Hub is the server where Docker images live. So creating a Docker account, I should be signed in. So I can push stuff up to my Docker Hub and publicly share it with other people is really useful, like say teammates. And if I had any containers running, I would see them here. I've got a bunch of exited and stopped containers from stuff from before, but we're going to focus a bit more on using the command line. And forgive me while I kind of maneuver my screens and get back to what I wanted with the Postgres Docker image. So now that I've started Docker desktop, I can just type Docker, and it's this command line program. It's got a ton of options. It is useful, I think, to kind of look over this list of options. Attach, commit. We don't use a ton. Create, we'll see later. Really, to be honest, inspect, kill, pause, rename, restart, remove to remove a container, start, stop. Those are the big ones. And then the same way I can run the PS command to see all the running processes on my computer that are running in the foreground, I can run Docker PS to see what containers I currently have running. And the answer is none. And Postgres very conveniently, sorry, I'm still getting, there we go, gives us the commands we need to run this container. And let me go ahead and type this out and talk about what it's going to do. So we're using the Docker command line interface, the client, to run a container. I'm going to give that container a name. I'm going to tell Docker some environment variables. Right, you guys have been putting these in a .env file. With Docker, we'll use shell scripts or Docker commands to create these environment variables that the containers need. And I know that I need this one because the docs for the Postgres Docker container tell me. And this is the password for the Postgres user. And I'm just going to make it be XYZ123. -D, I believe, runs it in the background. And then I give the name of the Docker image that I want to use. And if I did not have the image, as long as I had, I'm not sure if I had to sign into Docker Hub, but it would pull it down from Docker Hub. Now, I already have the Postgres image installed, so it isn't going to do that. Though actually, we can get rid of that image so we can watch this happen. And so let me hunt around here and find the Postgres image. Looks like I have two of them. Let's delete them. It does take up a decent amount of space. I don't know if you guys saw, but it was taking up about 500 megabytes. So you do want to manage your containers and images. And so now when I run this command, we're going to actually pull down the Docker image that has Postgres from Docker Hub. Nothing very exciting happened. But if I run Docker PS, I now see that I've got a running container. It's got an ID. It tells me what Docker image is being run. It lists the command used to run the container. Note that it's running on a port. Note that the port is 5432. By default, Postgres runs on port 5431, but I already have my system Postgres running. And then it's got a name. And now that I've done this, I can interact with this Docker container. And I might need to refer to my notes to remember how to do this the way I want to. So there we go. And let me pause and see if folks have questions, because I know I've been doing a lot of talking and jumping around from a lot of stuff. And now is a good time to jump in if there's things on people's minds. I know I haven't talked a lot about Docker files, and we saw a bunch of those, and that might have been a bit confusing. So I just want to check in if people are feeling comfortable thus far. We doing okay? We feeling lost in the woods? On a scale of 50 to 100, where we at? Like a 51, 52, 99, 73? Someone give me a number.
74.5.
74.5. Perfect. Thank you. Let me go ahead and connect to this container. And so, and to make a little TL draw, what I've got at the moment, and I'm not going to go like full on with all the levels and the layers because we understand that now. But I've got my computer running. And then inside that, I've got a Docker container named mydb1. And inside that is some sort of Linux, almost definitely Ubuntu, but let's just call it Linux. And that was a Docker image that someone created. And then whoever the Postgres people that made this official Postgres Docker image added Postgres to it. Right? And this is, so to speak, the stack of my container. Now, over here on my computer, I also have like Postgres running in the background, the Postgres that we all have that we installed, but this is not what we're going to use. What I want to do now is connect with pSQL or use this Postgres inside this Docker container. And containers can be running or stopped. So now that I have created that container, I can start it and I can stop it. So that's good as far as it goes, but let's actually do something with this and see what we do. There's a Docker command exec as an execute that I can use to interact with a running container. Now, I stands for interactive, T stands for terminal. This is going to open up a terminal, a shell that's connecting to the Linux inside this Docker container running on my computer. So instead of having a shell session running, I'm going to have a shell session essentially inside my shell session so I can talk to this Linux inside this Docker container. And I have to pass either the ID or the name of the Docker container, which is mydb1. And I need to tell Docker also what I want to do. And I could just do this, but that it needs a bit more. Let's try bash. Now I'm running a shell session that's inside this Linux over here. That, in fact, if we want to be pedantic, has Postgres running inside of it. And in fact, I should be able to use pSQL, except I probably need to pass the username, Postgres. I need to pass a port and some other stuff. This seems like a bit of a pain. Let's try like pSQL. I think it's -u Postgres. I think I just had it. I had it wrong. There we go. And so now inside that Docker container, I'm in. It's Postgres. There's not a lot in here. As you can see, I finally remembered how to list the databases with the pSQL command. There's a Postgres database, a template0 database, not a ton. Just for fun, let's create DB, inception inside container. And can someone actually remind me, how do I list all the databases?
Should be \D, maybe.
Oh yeah. And I think the issue, in fact, was the issue was my pSQL is rusty and my SQL is rusty.
Should be just \D. Oh, you got it.
Interesting. It's let me do a quick Google search. Postgres list databases, pSQL, /L. So there it is. It's hiding up at the top. And just for fun, I'll open up another shell session. We're not in Postgres at the moment, or we're not in the Docker container. This is the Postgres that's actually running on my operating system outside the container, the one that you guys have, and you can see totally different database. So this is all well and good. I can do this a bit more easily if I want. Rather than running that command in 2 steps, I can run it in 1. I've still got that container running. I didn't stop it. I can do, and I can stop it. And it's saved, the work that I've done. It's saved somewhere on the file system. It's in that image. It's there until I delete the container, then it would be gone. Let's execute with an interactive terminal so I can do stuff on my container. Let's, instead of running a shell session, let's just get straight to it and run pSQL and pass it the Postgres username that we need to pass. And that pops me right in to pSQL. So that's sort of like running a Docker container 101. If I hop over here, back to, let's go to containers. If I hop over here back to Docker desktop, we can see this container. It's got this visual interface that has all this fancy stuff. But in essence, we see that I've created this container that I can start and stop. Um, if I want to, I can go ahead and save this image. And let me make sure I have these steps right. Forgive me just 1 second. And yeah, I want the build command. So this will create a Docker image based off of a container or another image. And so what I should be able to do here is, though actually I apologize. I think I need a Docker file for this one, so I'm getting ahead a little bit. Yeah, I'll come back to that in just 1 minute. I apologize. Just to sort of recap, we can list all of our containers. We can list all of our containers not running with PS-A. I can list all of my images. And I can also delete an image or a container with the RM command. If I want to, like, let's delete that busy box one at the bottom from a while ago. Oh, and that's for deleting containers. So if I want to delete an old container, like say this one, which has Docker comes up with names. I've I've now deleted that container from before. So running a container is relatively easy. And just for fun, let me show you guys one more, and then I think we can do some questions, and then I'll maybe show Docker files, and I think that's a good stopping point for today. Let's look at something a little more interactive. Let's look at the Nginx web server on Docker. And let's look at how easy it is to run this. So we'll pull down an image. You don't need to do this if you don't want to, because when you run, it'll do it automatically. And then they have a great README here, and they've told you how to host this image. And this touches on some interesting things. This -v command stands for volume, and it's how you can share stuff on the file system of the operating system with the Docker container. Right? So let's say over here, what I want to do now is let's just um uh man, if I can remember. Does anyone remember like the emmet command to
It's like an exclamation point to start it.
thank you.
Just do exclamation point and then tab.
Oh my God. Thank you so much. Yeah, I don't use emmet nearly as much as I should. So this gives me an index HTML file. And just for fun, we can confirm it's where it should be. And so now, following their instructions here, we're gonna run the Nginx Docker image, and we're going to tell it to look on my operating system in the HTML directory for index.html. But we have to map that directory to, and let me make this a bit bigger so that copy isn't eating up space. Inside the Docker container for Nginx, right? Nginx is looking in a particular directory for stuff. And it's telling us that it's looking in, and let's go back. Let me find the Nginx one again. I'm not sure. Apologies. All of a sudden, my internet got crazy slow on me. There we go. Sorry about that. It's looking in /user/share/nginx/html. So what I need to do is in here, there's /user/share/nginx HTML. And then on my file system, I've got, whatever my current directory is /HTML, and then that index.html file. And I have to map these two things together. Right? I have to create a Docker volume that shares some of this file system so that Nginx has it where it needs it here inside the container, but it's grabbing it from my file system. And let me go ahead and run this command. And let's do ./HTML. And that ought to do it. I want to make sure I'm running this command correctly. I'm honestly not sure what the RO at the end of this does here for this volume. And then we're using the Nginx container, or the Nginx image, excuse me. And I goofed over here. This is the name of my server. So again, just to reiterate, we're doing Docker run. We're giving our container a name. We're mapping some volumes so that the HTML directory on my operating system is going to be mapped to this directory inside the container, which is where Nginx needs it. I don't know what the RO does. It does something, I'll find out. And then we're telling Docker to use the Nginx image. And now if I do Docker PS, we see that it's up and running. It's running on port 80. It's the name is my server. Let's see if I can access this on port 80 now. And I might need to expose a port as well. Yep, I missed this command here of exposing an external port. So just like we mapped volumes, we also need to map ports so that to go back to my TL draw, it's not just the volumes that need to be mapped, but Nginx here is running on port 80 right inside the container. But I need to explicitly tell Docker, hey, expose that port to my computer, but do it on a different one. Let's say port 8000. so that then on my computer I can have Chrome, and let's bring up Chrome here just for fun. Once that's exposed, I can point my browser to that port. So let me go ahead. I have to stop the running container. I'm going to bring up the command I ran before, and I'm going to add -p and map 80 inside the container to 8,000 outside the container. And it's already in use by a container. Of course, because it's easy to forget, run actually creates a new container. So what this error is telling me is, Adam, you already created a Docker container with this name. You created it, you started it, you stopped it. Let's try, and it's saved this configuration. I'm not sure if this will work to do Docker start my server. Yeah, so let's stop the server. I think it's already stopped. Let's remove it. Let's delete it. And now let's run that command again with the port mapping. And note now when I run this, I've mapped what should be the internal Docker port to port 8000 on my computer. And let's see if this works this time. And it does not, because I got this backwards, which is probably the biggest gotcha in the book. I got the 8080 and the 80 mixed up. It's the host on the left and the container on the right. So let's do the dance one more time. And fingers crossed, now this works. So all I've got here is hello. But the great thing is if I go over to VS Code, let's put something in our body here. And because Nginx is mapped to our file system, I think we get our hello world message because I've mapped these volumes. So if I change this file here, well, all that Nginx is doing inside the container is when it gets an HTTP request, it's going and it's grabbing that file. So there were a couple steps. I made a couple missteps along the way, but now we've got an Nginx server up and running inside a container, and it's got access to our host system. I've been doing a lot of talking and showing stuff, so I just want to check in and see what questions folks have. If there's parts of that that might be good to go over again, or what's on people's minds. I know this is a lot of stuff. How are we feeling on a scale of like, again, the 50 to 100? Like, did we go up or down? Somewhere in the middle?
Yeah, it's just a lot.
Yeah. So there's a lot of commands, and that's one of the tricky parts. To recap, to go back to this diagram to remind us of where we want to end up. We're going to end up with 3 different containers, one with Postgres, one with Django, one with Nginx, which, by the way, inside here, will also have our React JS code. And then once you have these in a container, you can push the images up to Docker Hub. The rest of the team can pull them down. And you can push these to AWS, to the cloud, and have your whole system, right? Just to kind of step back a bit and look at the big picture goal. Let me show one more thing, and then that'll be a good stopping point. So what I've been showing is sort of the manual way of doing things. Let me show you guys how to create a Docker file and from it build a Docker image. And we're going to do this for Postgres. And the convention is the Docker file is always named Docker file. So you put it inside a directory with the name of what we're going to do with it. Note that VS Code knows Docker files if I name it Docker file, so I get nice autocomplete. We're going to use the Postgres image. We're not going to do a ton. This is the Postgres image I was playing with. We're going to create an environment variable named Postgres user. And we're going to add another Postgres user to this database. We're going to give them, I'm going to set the password to. And let's say I want this Postgres to run on port 9999 for whatever reason. So we're using a base image of Postgres, but we're going to create a different user and add a password. We're going to create a Postgres database too that we're going to access. And this one's going to be a little bit of copy paste that I'm borrowing. I'm not sure it's strictly necessary, to be totally honest, but it's just sort of better safe than sorry. Some arguments for Postgres encoding and some other stuff. I'm honestly not sure what it does. So we've created these environment variables, but this user doesn't exist yet, and this database doesn't exist yet in this Postgres. When we run this Docker file, when we run this image, let's run from the command line the create db command and create one called, I'm going to make this simple. Let's call it, let's just call it awesome. We'll name the user awesome. And we'll name the database awesome. So I don't have to do as much work. And if I wanted to, I could do more stuff here. But now we need to run the main command of our container. And we use command, and this is sort of the key command that gets run. And we always want Postgres to run when we run a container that we build off of this image. So this was sort of the official Postgres Docker image has some sort of Docker file like this. Now that I have this, let's see what to do with it. I'm going to just navigate into the Postgres directory. I'm going to do Docker build dash T, and let's call it my awesome DB dot. And what was the error I ran into? Creating socket, error connection to socket, on port 5432 failed. So that may actually not work because of how like Postgres and this base image is configured because it exposes on port 5432. So I think that was what was causing that error. Let's try that one more time. Let's see. I'm pretty sure the issue here is I may not have Postgres starting. Um, let's see here. Connection to socket failed. No such file directory. Is the server running locally and available on that socket? I suspect. Let's see, port 5432, command user. I wonder if folks, forgive me. I'm actually going to cheat in the interests of time here. Oh, yes. Did someone have a thought or maybe see what I did wrong there? So again, I'm totally cheating here a bit because I'm using Chat GPT. But I just want to get this fixed and up and running. And indeed, it's what I thought. The Postgres server isn't running yet. Yeah, and this I think is a bit too complicated. This is not quite the way I want to do it. This will run it when container starts. Copy init Docker entry point. Yeah, what I wanted to do is during the build step, I want to create the user and database. Yeah, I don't like the way that ChatGPT is telling me to do this. I think if I can't get this working, I'll probably just pause, but I suspect just doing that may move us forward. Let's see if that helps fix this. The root execution of Postgres is not permitted. Yeah. Okay, so we'll pause this. It
In
does
the Docker file in the curriculum, it just has entry point Docker entry point.sh instead of the run command.
Oh, let's take a look. I may have been looking at the wrong. I have some notes as well. Let's see
I
if
threw
that
it in
takes
the
care of
chat.
it. 5432 container DB args. Oh, so this does use the same approach. It creates a shell script. Okay, I didn't want to do it this way, but maybe, yeah, and of course it doesn't have the shell script. So maybe this is the way to do this. I'd actually like to improve this a bit because what I really want is I want this stuff to be created already. Um, but let's see how this works for us. And let's try it their way. Postgres user, Postgres password. Yeah, so what we're doing here is the entry point is sort of the first thing that gets run when the container runs. And then we're using these environment variables to create a database with this name. Let's see if this one works for us. Um, oh, and then of course this needs to be removed. Okay, that was a good call. Thank you. I appreciate that. Um, I'll kind of put together a better write-up of this later and sort of why we need this extra entry point step. But in essence, like this stuff gets run, Postgres gets run, then the shell script gets run once Postgres is already running. What I've done now is if I list all my Docker images, here's my awesome DB. Or excuse me, where's the one that I just created? Let's see here. Let me give it a new name because I already had an image with that same name. Let's just call it the awesome DB. There we go. Though I'm not sure why it says 5 months ago there. Um, yeah, I'm a little confused why it said it was created months ago when we just made it just now. Yeah, same thing. I wanted to make sure I didn't have yet because I kind of use the same names for stuff. But so we have this image, and now I can run this the same way I did with Postgres. DB9876, same password. The Postgres username should already be configured. But so now what I've got is a container running from the Docker image that I created. And this isn't that impressive on its own, but as we delve into this more tomorrow, we'll see how to do this with Postgres as well, or excuse me, with Django as well. And that's where it starts to get more interesting, where we can have Postgres and Django together and set up. And then finally, just to sort of take this home, let's see, Docker push DB9876. Requested access to the resource is denied. Let's see, I should be logged in.
Your mic is hot, Sam.
Got it. Thanks.
There we go. Okay, my apologies, folks. I had logged in on Docker desktop, but I forgot on the command line, I have to run the Docker login command. And now I should be able to do Docker push DB9876. And it still doesn't want to do it. So my apologies. There's a couple things I didn't anticipate here. What I was hoping to do was, now that I've created that image, push it up to Docker Hub. But I may just be on the wrong account, or I may have the wrong username set up. But that would be the final step here, and that's how you then share these images with each other. So I realize I jumped over a lot of ground today, and I think tomorrow we'll just do a bit of review of this before we dive into Django. But just to recap, and also because we've ran long, we've seen Docker containers and images, and what we see now is the basic creation of a Docker file that we can actually use to build our own Docker image. And then once I have that, I can check this into version control. I can add things. I can do all sorts of stuff. For instance, here we create a database. If we wanted to maybe add things in the database or add tables, we could do it here. Tomorrow we'll see how to add Django and apply migrations. And this Docker file can get saved into version control. And then once this image is created and pushed, we can actually use that same image in other Docker files, which is where it starts to get interesting. And also you can share the image with other people on our team. So I think this is probably a good stopping point, also because I know I've jumped around a bit. But before we wrap up, I just want to see if folks have questions or there's parts that might be useful to review and go over, as I know I covered a lot of ground here. And I think this is probably the good image for us to look at the moment. Is there anything on people's minds that might be good to dig into a bit more? Okay, and I know this was a lot of stuff. How are we feeling about the basic idea of a container, and a container runs an image? Pretty good? Okay, awesome. The devil's in the details for a lot of this other stuff. And we do need to organize the curriculum a bit more. And I was working off of some other notes. But in the main README here, it does cover a lot of ground and has some good getting started. And this might actually be the best place to start. James, yes, sir.
When you say sharing the images when you're collaborating with your team, is that just like sharing the requirements.txt, or is it similar to something else?
Yeah, that's a great question. So there's two pieces. One piece is like requirements.txt, we would check this Docker file into the GitHub repo for the team, and teammates could use that to build images. And a lot of the times that's what you all would do, is you would build images off of the Docker file, especially as it changes. But the step I wanted to show, and I ran into trouble for some reason because I have to figure out something with my user account, was once I build an image using a Docker file, I can push it up to Docker Hub. And I can show you guys some ones that I created before, even though I'm running into, I'm not sure what the permission issue is. And here's one that I think is for Django named API prod. And let's see if we can. I'm just looking for something, if there's something good for us to see here. I didn't link this one to a repository. So this is where documentation is important, because if someone else was looking at this, they wouldn't really know what it is. But what this is Django Dockerized and pushed up as an image. And you can see it here, but it's a little hard to understand it this way, like all of these commands. But you can see Python gets installed, Python gets run. I copy a requirements.txt that has a whole bunch of Django stuff. And here's GUnicorn that gets installed and run. So this is the final step that I was trying to show with the image I created for Postgres. And this isn't very useful, which is why you need documentation. But like once you've created an image with your Docker file, whether it's for Postgres or Django, or if your team decides for convenience you want to put all of them in one image, it's not just the Docker file that you can share, but the image that has, the whole application and everything set up, if that makes sense. And then you can do Docker pull, like my team's API, to say pull down the Django API server that's already in a Docker container, and using just one or two commands, run it the same way I was with Nginx and Postgres before. Does that help answer your question?
Yes.
It sounds like maybe I got a little too in the weeds on some parts there. Yeah, the short answer is for the team, for local development, you'll use the Docker file because it's probably easier. Where the image really helps is deploying to AWS, because you all, I know this was a while ago, but do you guys remember the AWS deployment lesson? Does that ring a bell with the EC2? Did we go over that?
We never had
I
the
don't think we did the
AWS.
AWS deployment
Okay,
lesson.
got it. Okay, I think we pushed that back to give you guys a bit more work time. Um, so we'll do that as we get closer to the end of group projects. But this actually will be useful to go over briefly, and then I think we have got a good stopping point. How many people have started that AWS course, by the way? I know the way it was introduced was painful, but it really is valuable. Just if you started it, let me just see a hand. Okay, so a couple folks. So when you guys deploy to Amazon Web Services to the cloud so that your application can be live and used by other people, there's going to be 3 bits. You've got to put the database there. You've got to put Django there. And then we like you to put a web server called Nginx there. That's basically for hosting static files like HTML files, or a JavaScript file is a static file, like say your actual React app. Like if you run npm run build in your front end code, it will create what's called a bundle, which is like the sort of compressed, minified file that has all the JavaScript and all the CSS and all the image assets. And so the user's browser will talk to Nginx, and Nginx will send them back the React app. But then when the React app makes API calls, they still pass through Nginx, because it's a good idea to have a web server like this sort of in a front layer, and it does a couple things. And then Django talks to Postgres. And when we deploy this to the cloud, we have options. One option is it all runs on a single server, what's called an EC2 for elastic compute, which is definitely going to be a virtual machine in the cloud. Excuse me. This is honestly the easiest way in terms of practicality, and it's probably what we'll have you all do. And there's some extra steps, but this is the basic idea. But in real world environments, because for the reasons I was talking before about scalability and also maintainability, like especially if I have other systems using the database, I might not want the database to crash if there's a problem with the Django API. I might want to deploy this as separate servers. But even if it's all on one server, how do I install Postgres? How do I install Django? Am I going to have to, SSH into my EC2 server and then do, pip install R requirements txt, create DB, my team's DB, Python, source, then bin, activate, Python, manage, py, migrate, Python, manage, py, run server. Am I going to have to do this manually? What happens when we add a new table to the database or we change our code and then I need to run these commands again? Well, maybe I put this all in a shell script, like install run app.sh that does all this stuff. And that makes life a lot easier because now I have a repeatable shell script. But, there's still things that can go wrong. Do I need to install Postgres? What if there's a version change to one of these that isn't tracked well here? What if something else changes? There's just a lot of little things that can go wrong when you set up an environment, as you all have learned from managing your own. So the best way is I don't have to run all this on the server. Instead, I have a container. And again, it could be one container. 3 is a bit more real world, but 1 does the job and it keeps it simple. Sorry, this arrow is killing me. And all that stuff that we needed to do, we do with a shell script or we do with Docker files. And I've got then a Docker image. And using Docker push and pull with Docker Hub, which I couldn't demo because I have a login issue. But the same way with you can push your code to GitHub and then pull it down really anywhere else, we can do the same thing where you guys have those Docker files in version control. you create the images that have your whole application, you push them up to Docker Hub, and then all we need to do here on this server in the cloud, I SSH into my server, I run Docker pull, and in essence, Docker run, my team's image. And maybe there's a shell script for this, but all of a sudden there's way less commands, there's way less manual steps, and I don't have to worry about something going wrong in like one of 20 build steps because the whole application environment is already built. Right. And this is like the real value add of Docker. And that was a very long answer to a short question, James. But does that help illustrate a bit more of what the end game is here?
Absolutely.
Awesome. Yeah. And if anything, this is probably the takeaway from today, folks. I'll make sure to have things a bit more organized for tomorrow. And we can get a bit more into the nitty-gritty of running and using and working with Docker. But this is really the takeaway I want you all to have from today. That what Docker does for us is when we need to deploy our application to the cloud, to a production environment or a staging environment, because there's not just one environment that we work in. I have this drawing hiding somewhere. Let me pull up the drawing that I want. Give me 1 sec here. And then we really will wrap up because I realize I've gone way over time. And the drawing I want is this one. I've got it on the TL draw somewhere. I'm not sure where I put it. But in a real world production environment, there's not just the live app, on what we call production. We might have a QA environment for the QA team to test stuff in a real world scenario with test data. We might have a staging environment so that, as developers, we can deploy the code we're working on onto the cloud and make sure that it really works, not just on my computer. If the team is big enough, there might be 2 staging environments. Right? So when you're doing software engineering, you've got local dev, you've got your laptop, and this is really 5 different people's laptops because you're a team. And so Docker can help with this. Then you might want to deploy to a staging environment to test out your work for yourself in the cloud to make sure there's not something you missed. Depending on how many environments there are, it might get sent then to a QA environment for the QA team to test manually. Maybe the VP of product looks at it on the staging environment as well. Especially if the team is remote, the VP of product might not be able to walk over to your laptop to see a demo, and they want to be able to interact with it. And then once it's finally done, we need to deploy it to our production environment, to the actual live site. Right? So these could all be different cloud environments. And this is where Docker and containers and all these steps and all the port bindings and the environment variables really come into their own. Because there's a lot of configurability, but then all of a sudden I can really consistently deploy a whole application stack anywhere I want. And that's the big picture here. And I think that's the main takeaway from today. Tomorrow I'll have things a bit better organized so we can delve into details and get our hands dirty with Docker. But hopefully today, if nothing else, painted the picture for you of where we want to end up and why this technology is so useful. Any other questions on people's minds before we wrap? Okay, and I'll make sure that this diagram makes it into our demos and notes as well. Thank you all for being patient. I hope this was useful. this will be good because by the end of the class, you guys can Dockerize your group projects and deploy it onto AWS, and that will be a great feather in your cap, both in terms of like experience satisfaction and to put on your resume. So thank you very much, folks. I'll stick around a bit if folks have questions, and I'll double check the schedule, but otherwise I think it's a coding day. Thank you. Let me go ahead and stop our recording.